It's seven segment interface, seven segment display interface. First, we have used hardware, seven segment display hardware. Okay, so let us see how the procedure is same. The Proteus execution procedure remains the same. Okay, only the connection we have to look into. It's very easy. So these symbols, if you see, these uh, seven segment displays symbols are that kind of the kind which are used in Proteus software. Okay, so we'll look into that difference here. For example, this is a common anode seven segment display. In this, we can see that that common anode connection, that is positive supply, is connected to the positive point is shown above the the seven segment display. Okay, this indicates it's a plus VCC, common anode, for a common anode. Okay, on the left hand side we can see the pins. In physically, what happens? The pins are at the top as well as at the bottom. So this is the physical structure of a seven segment display. Similarly, when we see the that of common cathode connection, this common point is the ground. That is pin number 3. Pin number 3 is the ground. Pin number 3 or 8. Pin number 3 or 8. Similarly, in a common anode, pin number 3 or 8 are connected to VCC. Are connected to plus VCC. Okay. So the pins are represented on the one side of a seven segment display in the Proteus software. Uh, we can physically we have the pins on the one side of a either side of the seven segment display physical structure. Okay, so the same thing we have in our Proteus software also. This is the table that is okay. Now let us look into the Proteus software. Yes, so, okay, so let me say this and let me close this. Close project. Yes, save. It's already running. It is running. So okay, here we go. Here we go. Close project. I don't know, it is not saving. Okay, here we go, no problem. Done. Okay, that's the component. Oh, no, no, it's zoomed in. They do not. Simulation is off. File, close project. Yes, save changes. So it is, I think I should say, close project. No. Okay, fine. Here we go. New project. Let us call it as um, seven segment. Same procedure. I think by now you guys are no, familiar. Better to install the software and start reading. Software is very useful for your project also. Okay. Anyway, here we go. With the components, what we require now is because in the seven segment display we have two programs, 7A, 7B. In 7A, it's just interface of seven segment display to the microcontroller. Okay, so there is no other connection as it is. Whereas when it comes to the seventh B program, okay, it is the interface of seven segment display, which displays the counter, count of pulses at a different speed, which is controlled using a switch. Which is controlled using a switch. So both can be done. So both experiment can be conducted. Okay. So first, let us start with the first experiment where we interface only the controller to the seven segment display. 8089C 51 because 8089 yes 52 is not available. So 8089C 51 is very close to 8089 S52 in terms of its characteristics. Okay. So next is the seven segment display. Okay. It is on the line. Okay. So when it comes to seven segment display, there are different types of seven segment display we can find in Proteus software. Okay, you can see the controllers also. Okay, so mainly what we the different colors also, as we can see in this document, different colors. In fact, I think this is taken from the Proteus software only. So we can see different colors, green color, blue color. Okay, um, Here we have two types. We can that you can notice here. Common anode, you'll have the the VCC at the top, that we can notice here, VCC at the top. Whereas when you go for common, that is a common cathode. Okay, so this is a blue color common cathode sensing display. We can see that the pin, that is a 3 or 8 common point, is given at the bottom, that indicates it's a common point. Okay, the one which is given at the top indicates VCC. Very easy to identify, common anode and common cathode type of 7 segment display. So let us pick one. We can take any one of them, not an issue. Okay, here the common anode. Let us pick common anode. In that we have different colors. Whichever you think it is suitable, you can pick one. Okay, uh, you can place it here some area, so that we can interface the 7 segment display to port 2. So that no, I think the program, it is for port 1 works, no problem. But in case if the P1.6 problem comes, so better to connect to port 2. Okay, the C program. Okay, it's port 1, no issues. So we can change it to port 1, not an issue. Okay, there we go. Because port 2, what happens, it is yeah, port 1 is somewhere here. When it comes to Samsung display, you can select, and you can change its orientation, rotate 180-degree rotation like this. All this is possible. Okay, so accordingly you can place the 7 segment display. Okay, so this at the top is the pin number A, the bottom is the pin number G. Okay, so accordingly we can connect it to port. Okay, here we go. Oh, sorry, I'm trying to connect. Okay, first is using the no connection to the port 2. This is very simple. Once we know, if you're familiar with one circuit, it becomes very easy to connect the other circuits. There is a common anode 7 segment display. This P 2.7, we can keep it open, not an issue, because by default it takes 0 anyway. So what we want is VCC, because this is a common anode. We are connecting it to VCC. Okay, pin number 3 or 8 connected to VCC. Okay, so the connection is very simple. Here, that's all. Okay, um, let us pick no, the switch also for our 7th B experiment. We can go to this push button switches. Not yet. So component mode. Go to E for part display. Okay, part selection. Here it is, push button. If you search push button, it straight away leads to only one option. Lesser the option, lesser the confusion. So better to pick, place it here. Accordingly, you can rotate. You can, this is better. This orientation is better. So the switch, we can connect to any pin, P2, P1.0, or any pin. Not an issue. Okay. Um, okay. Let us do this later. First, let us execute. You know. 7th A. Okay. Yes. Here we go. Let me run in the what do you call the kill compiler to generate the Xcode. We can generate using Proteus also, not an issue. Okay, that's also possible. But maybe we are familiar with the kill compiler. Maybe that must be the reason. Okay, let us try the C program. Assembly should also work, but there will be difference in terms of whether it's assembly or C, because Xcode size is going to change as we change the assembly, as we change the programming language. Okay, C generates a higher, heavier Xcode than the assembly, but C is because of its popularity, we can and because of its convenience, we are going for C programming language. Okay, it's easy to code than compared to assembly. Okay, there's any other changes we have to do, because these values, is it for common anode or common cathode? We, this is 7E, because I've connected common anode, so this should be common connected common anode. Okay, I have to change the value in the port. 1 second. 4F, 4FH should be capital because in C, small f and capital F are different, so you have to be careful. It may display some other character. Okay, 06 after 06 because it is a common anode for C. Okay, 2, 4, 0 after 60 0 F. I think the next is 00 and 0C. Okay, here we go. So this is common anode. So these values are for the common anode connection. Okay. So I changed it to port 2 here because I connected the the 7 segment display to port 2. Yes. Yes. So this wait is asking. Let me say this. Okay. Say let us call it as 7 dot 7 dot C. Okay. Add existing file to the okay, 7.c. Add close one. The target to check for the it is asking for the other file. Okay, this one no. Same changes to this is close. Yes. Yes, hold on a second. I'm trying. Should say a no there. Otherwise, it is asking to save the file. Right click to close. No. Okay, here we go. Okay. So no errors. Rebuild on. Of course, I have enabled export generation, so it is saved on the desktop LCD. Earlier program was LCD, so that's why it's taking. You can change it. Name of the executable file. You can change it to 7. The file now will be 7.x. So it will just generated. You can see that the X code now is 7.x. Okay, here we go. Compiler, the Proteus software. Right click, edit properties. The path is uh, desktop 7x open. Okay, everything goes well. That should display the. Okay, this is the. Okay, wait. It is displaying some no, random characters. We'll connect with this. Wait. And, mm, not box. This should be ground. Okay. Oh no, I made a mistake here. Because what is the mistake is the yeah, here we go. The mistake is P2 dot 6 should go to A. I have connected ulta. That's why it is giving some really random characters. What we have to do now is we have to make connections such that that is yeah, here we go. The connection looks quite know, or else we have to calculate recalculate the value such that P2 dot 0 is connected to A and no, P2 dot 6 is connected to G. That's also possible. So for time being, let me connect like this. Okay, usually nobody does like this anyway. Okay. So P2 dot 7 are connected to ground so that it is 0. Even otherwise it can be open, not an issue. So with this 0, okay, that one. The values were the pins were wrongly connected. No, interface. Okay, so this is for the up counter. So even for the down counter, what changes we have to make in the program. We have to go through the down counter. Yes, what changes we can make is in down counter. Can somebody suggest for down counter? So what we are executing for counter now? For down counter, what should be the case? So this should be we should start with uh, 10. No, I should start with 9. I less than I greater than or equal to 0, 0, I minus minus. This should provide the down counter. So we are starting from the last count. We are going towards the first count, first element of the array. Let us check this program for the down counter. So make sure that the path is say export. It is on the desktop in my case. Now it's a down counter. Okay. So we are counting from 9 to 0. So reverse the array, not reverse the array. Start from the last element. Okay. Okay. Some issue with the with the though it has started with greater than or equal to 0. What should be the case? Because it is stopped counting now. Is equal to 9 now. Okay. Last element is 9. Greater than or equal to 0. I minus minus. Mm, okay. It should work. It has stopped executing. Let me check on my time. So it's starting with 9, that's not an issue. But once it reaches 0, greater than or equal to 0. Okay. Here it is displaying some random characters. If it is I, rebuild all. So I think now it will not display the 0 character. Maybe let's check. Starts with 9, 8, 7, 6, 5, 4, 3, 2, 1. No? Oh yes, correct. It missed the first character 0. So sorry, the last character 0 because it is given as I greater than 0 should be mm, greater than or equal to 0. This must be the case. We will down. Okay. Okay. So here we go. This next is but it's why it is not continuing the value of I starting with 9 now. 9 minus 1 is correct. Okay. Anyway. Yes, next is with B, seventh B is using the switch. Switch is connected to in seventh B. Of course, you can use any pin. I think we have used P2 P3.0. Switch is connected to P3. We can use any pin. Let us use the okay P3.0. Um, okay. Component mode selection. Just a second, because I need to okay straight away. Let me connect this to um, P3.0 um, and okay sorry we have to connect VCC also, not this simple connection for the switch. This is drive the object. Okay, let's connect somewhere here. Okay, here we go. Mm, so we need the resistor for the, otherwise it will be a short between VCC and ground. We can use a 10K resistor. So straight away you'll get 10K resistor. No? You go to DG key component somewhere here. You'll get a fixed 10K. There are different values. You can pick 10K. Okay, so straight away you'll get 10K. Here it is. So this is, let us rotate. so that we can doesn't look too awkward. Okay, here we go. So next we want the ground. So here it is, the ground connection. Okay, and next we want to, what we want is VCC. Of course, VCC is already there. So let us pick one more here. It's here, yeah. Yeah. So this junction of should go to P3 dot 0. So this is the connection for the switch, okay. And the program is 7th B. So here the again we have to change it to port to outputs because we have connected 7 segment display to port 2. So let me change the same modify the same program. So the value here this should be P2, which is equal to 1 P2. The 7 segment display is connected to P2 and switch is connected to P3. That's okay. P3 dot 0. Rebuild all files. Okay. So it has generated the hex code. Make sure that it has generated the hex code. Yeah, here we go. Yes. So switch is interface to the P3.0. So what kind of logic is this, guys? Switch connection. When the switch is pressed, the pin is shorted to VCC. If the switch is released, pin is shorted to ground. So pressed, the value is 1. Released, the value is 0. It is a positive logic. Okay. So we can either go for positive or negative logic anyway. It works. No problem. Now we have the simulation. Okay. Okay, common cathode, correct. The values, I think here it is connect. Is again I have to change the value. It is showing some random characters, some ASCII characters. So we have to feed the values for the common anode. 0, 1, and let's say 4, 4, 1, 2, 0, 6, 4C, 4C, 2, 4, 2, 4, 0, 0, 0, 0, I think 0, 6, okay. 0, 6, okay, here we go. So each time you change the source code, rebuild all target files so that text code is generated. Okay, so stop the simulation and you can run again because the path is same. So the path has not changed. So it's a up count with higher delay when the switch is not pressed. When the switch is pressed, not change in, okay. Not change in delay. Okay, because when the switch is pressed, interval of 1 second, the switch is connected to, okay, 2 seconds if the switch is connected, okay, not pressed to 2 seconds. So pressed it should be 1 second, but what we find is not much of a difference. In the beginning, once the switch is pressed, it looks like it is faster. So what changes we have to do here is in the main program, okay, set IT 0 to 1. It's not interrupt enabled. Sorry, it's not interrupt enabled. It's just a switch. Okay, okay, just switch connection. We have to change the program in that case. Mm, delay is pressed. We have to reduce the delay so that we can achieve this, mm, switch is pressed to higher delay. Switch is released to lower delay. Okay. So here on delay value we have to change it, but it's 1 second anyway. There's not much of difference. Timer 0. Okay, this is okay. We will target. Okay. Let's simulate again so that let us check in case of any major difference when the switch is pressed. One delay is almost no like it looks like not pressed. It should be 2 seconds. If pressed, uh, once pressed, it immediately no changes the state, but delay is almost 2 seconds. Delay. Okay, we have to change and modify the code when pressed. Delay should be okay. The question is when the at the interval of 1 second, if the switch is connected to is pressed at an interval of 2 seconds. Okay, okay. Now, what is the possibility here is that we can change the logic of the switch of a switch. 7 segment display we can't help because it's already it's a fixed connection. Either we can go for a positive logic. What we have connected now is a positive logic. Negative logic, the switch connection will be different and it may make some difference. Let us try with the negative logic. Okay, in the negative logic, this switch and the resistor position should exchange, swap. That's all. Okay, so let me try with the negative logic. Instead of modifying the code, what we do is we change the logic itself, switch logic. So the this this let the this one let it come here so that here it is. Now it is a negative logic. Negative logic. Okay, no problem. So let's connect mm, the switch to the ground. Switch to the ground. Sorry. Yes, here it is. Okay, here we go. Okay, so junction of resistor and switch to P3.0, P3.0, P3.0. Okay, here we go. So let us see in case if this can make some difference in delay. Okay, not pressed 2 seconds. Maybe slightly higher than 2 seconds, of course. Depending on the compiler, as we understood. Timer delay depends on the program. ಇಲ್ಲ ಇಲ್ಲ ಏಕೆ ಜಸ್ಟ್ ಅ ಸೆಕೆಂಡ್ ಏನಕ್ಕೆ ಈಗ ಲ್ಯಾಬ್ ಬೇಕು ಇಲ್ಲಿ ಬಿಡಿ ನಾನು ಬರ್ತಿದ್ದೀನಿ ಟೆಸ್ಟ್ ಮಾಡ್ತಿದ್ದೆ ಲ್ಯಾಬ್ ಶುರು ಆಯ್ತಲ್ಲ ಆಮೇಲೆ ನೋಡೋಣ ಆಮೇಲೆ ಕಳಿಸಿ ಥ್ಯಾಂಕ್ ಯು. Okay, so 2 seconds. The switch not pressed 2 seconds. Let us see with the switch pressed. But okay, somewhat different. No? So the difference we can see. Difference we can notice. Okay. So what is suggested is okay. Because why this changes is because in the what we are using is a negative logic. That not advantage. The difference between positive and negative logic is in this case when the switch is pressed. Okay, the pin is connected to 0. Okay, logic 0 not pressed, the pin is connected to logic 1. This will decide the the operation. Okay, if because when we see the program what we have the program what we have written is if switch is pressed then actually it should be 1 second delay, not pressed 2 second delay. No, correct. Just a second. Switch pressed 1 second, which not pressed 2 seconds. Okay, yes, here it is. Okay, here it is. I'll explain that case. We'll understand the difference. So in the switch interval of 1 second, if the switch is connected to is pressed and not pressed, then it is 2 seconds. Okay. So thereby what happens here again? Here is that uh, the pin. If you see the if switch is equal to 1, When the switch will be equal to 1, when the pin is set to 1, that means switch is connected to P3.0. Okay, switch is equal to 1 means this pin should be 1. For 1, the condition is not in a negative logic. When we check in the negative logic, when the switch is not pressed, it is equal to 1. That means this is switch pressed. In a negative logic, this is switch pressed. In a positive logic, this is switch not pressed. This condition is switch not pressed. Not pressed. Okay, so thereby when switch pressed means physically not pressed in case of a negative logic, which is equal to 1, it will generate 1 second delay. 1 second delay. Not pressed means switch open in case of a negative logic, because that will send a 0 to the, sorry, when switch is pressed in negative logic, that is not pressed for a switch, because it will send 0 to the pin, then it will generate 2 second delay. 2 second delay. Okay, so thereby in the hardware also, guys, what is suggested is, of course we have to change in the program, that is for sure. We can modify the program accordingly, we can change the delay, no doubt. But in case if this, see, simply we cannot go on increasing the delay, what I suggest is try to change the logic of the switch from positive to negative. That will help, that will work. Okay, if this was a positive logic, what would have happened? Switch was here. When the switch is not pressed, it corresponds to 0. Switch pressed, it corresponds to 1. In case of a this is positive logic. In case of a negative logic, the reverse. Pressed corresponds to 0, not pressed corresponds to 1. Okay, and one more thing, what you can observe the switch is, for this, since it is a push button switch, we have to keep it pressed for it to be, the switch to be 1, the pin to be set to 1, for P3.0 to be at logic 1. Okay, what is required is we have to keep the switch pressed. We have to keep it switch pressed. Okay, this is required in a negative logic, where when it is pressed, it corresponds to logic 0. It corresponds to logic 0. That is, we have to keep it pressed continuously. Okay, so then the pin is set to 0. If the released, the pin is set to 1, because it is released, the switch is pin is connected to VCC. Okay, so based on this, the positive logic and negative logic, the operation also changes. So what I suggest is, in the hardware also, try to change the pin logic, switch logic from positive to negative, and then try it. So simply we cannot jump to the conclusion that there is an issue with the program, or hardware, or display device, something like that. Okay, so we can cross check with the switch also. Here we go. Okay, so since it is a push button, when pressed, the delay is 1 second. We can observe slightly less than 1 second maybe. Switch not pressed, delay is approximately 2 seconds. That's all. Yes, okay. So this is about 7 segment display. Um, Similarly, we have exercise program in uh, seven, seventh experiment. Yes, we have exercise program starting from the sixth experiment. Okay, sixth C. Okay, and similarly seventh C. In seventh C, write an embedded C program to continuously count 1 to 8 and stop on press of a switch. So the count should stop on the press of a switch. So when press of a switch, we should consider the logic. Okay, so logic may be, when switch is pressed, it may be 0 or it may be 1. Okay, so in which logic it will give 0? When switch is pressed, in which logic the pin will be 0? It is in negative logic. Okay, in positive logic, when the switch is pressed, okay, the pin is set to 1. That is in case of a what is known as positive logic. Okay, yeah. So the count should stop at the count being displayed on the 7 segment display. That means it is counting from 1 to 8. When the switch is pressed, the count should stop. Okay, so whatever the count it is, for example, it was at fifth count or sixth count, it should stop at that particular. It should, that means when the switch is pressed, it should not go to 1 or it should not go to 8. It should be either at 5 or at 6, wherever it is, wherever it was stopped. So that's about guys, the sixth sorry, 7C exercise program. Similarly, 6th C, I think many of you have done 6th C, I guess. Okay. In this case, four LEDs. First two LEDs will blink at two different speed. First LED is 1 second delay. Second LED around 2.5 seconds delay. Third LED will change its state when one switch is pressed, and fourth LED will change its state when another switch is pressed. That's what it is. Okay. So this should be LED. No switch. LED 4. Fourth LED. Okay. Yeah. There we go. Seventh C. Similarly, eight is, I think 8C we discussed last class. I mean, no, program wise. So write a program in C to control the display of a message on the LCD display using two buttons in the following pattern. Two push buttons, of course. Um, so two push buttons, there are four possibilities. Okay. So the first possibility, no buttons pressed. Um, Press 1 for yes, 2 for no. That is, first switch is pressed, should display yes or it is no. One pressed, display yes or no. Both are pressed, it is an invalid entry. It should display invalid entry. Okay. No button pressed, it should say press 1 for yes, 2 for no. So additional features, add a toggle switch which can be used to enable or disable the scrolling message on the LCD screen. Guys, for this we have to change the command. There is a display can be scrolling or static, that can be controlled using a switch, additional toggle switch. It is nothing but a push button switch. Toggle switch is nothing but a push button switch. Okay? So with a push button switch, we should be able to select scrolling message or static message. Um and uh, that's in addition to this function. Okay, so for that, this scrolling of a message, we have in the last class we have discussed various commands are used to control the display of data on the 7 segment display. So sorry, not 7 segment display, LCD display. Sorry, here we go. Okay, yes, that's about 8C. Next is ninth program. Ninth again, it is 9A, 9B can be considered as ninth program. Ninth C and ninth D is a 10th program. It's exercise programs. Okay, so based on the experience of performing 8 experiments, so we should be able to conduct ninth experiment, ninth and 10th in simple words. That's okay. So with this, guys, if you write this, if you learn the programming for these experiments, um, you're familiar with the of course, hardware interface. We are using basic components, no doubt. You're familiar with the basic component interface to the microcontroller, as well as programming of those components. And with this knowledge, you can develop complex systems, embedded systems. Is that okay? So what I suggest is practice this program. Since if you have an hardware, you can, if you have access to hardware, you can practice on hardware, or at least using the um, Proteus software. That's okay, madam. Okay, ಅಲ್ಲ madam, ಸಾಕಲ್ಲ?
Sir, ಸಾಕು sir.
Okay, sorry. Thank you. Thank you, madam. Yes, thank you. Thank you. See you
We
in
can
the
close.
next one. Bye. Bye.